Okay, for these notes, it's a quick one, greatest common factor. You'll see here the definitions. A factor is something that is multiplied, and so 2 and 3 are factors of 6, 1 and 6 are also factors of 6. The greatest common factor is when you're looking at 2 or more numbers and you're looking for, again, think of the different definitions. Factor, part of the piece that multiplies them. Common, those parts that are in common, and we want the greatest one of those. So if you look at all of the factors of 2 or more numbers, what do they have in common? Pick the largest number that can divide into both equally. And by equally, I mean with no remainder. So when we go to the next slide, there's a couple ways to do this. 9 and 6, you can do these in your head, but I want to show you another way as well. I did the prime factors of 9 and the prime factors of 6. Prime factors are like the factor trees, breaking it down as far as you can go. I saw they have a common factor of 3, so that's the GCF. You can try the other 3 by pushing pause and then coming back, so I'll let you push pause now. All right, for the other ones, you can see I broke down the 20 and the 24 here. You'll see I left a space because I like to put the common factors underneath each other. I had a common factor of 2 here and another common factor of 2 here. Notice I didn't try to include this one. It has to be a 1-to-1 match. So when I bring down all the common factors, you then multiply them. So the greatest common factor here is 4. Yes, they can both be divided by 2, but I want the biggest number that can divide into both, which in this case is 4. 54 and 36. A lot of people had trouble with this one in class. They were saying it was 9 or 6. The truth is actually it is 18 if you look at the breakdown here. For 19 and 21, we don't normally write the 1 as a factor, but 19 is prime. And if they don't have any common factors, their GCF, they do have a GCF of 1, and we call these numbers relatively prime. Now we're going to follow that same logic with x's. So again, prime factors of x to the 7th. Well, that's easy, 7 x's in a row. Prime factors of x squared, 2 x's. And what do they have in common? 2 x's, which gives me x squared. X times x is x squared. We just covered that in chapter 9. So the greatest common factor of these two is x squared. So I'd like you to try it, push pause, try the next two. Look for some relationships you're seeing, and I'm hoping you'll be able to do that here. So push pause and then move on. All right, as we come back, you can see my work here. Greatest common factor of these two was x to the 3rd. Greatest common factor here was x. And you may notice that it always ended up being the one with the lower exponent. So following that logic, the greatest common factor of x to the 100 and x to the 81st is x to the 81st. And you can kind of visualize that too. 100 x's across the top, 81 x's across the bottom. How many do they have in common? So when finding the GCF of two variables with the same pace, the GCF will be the variable to the lower power. You can put that in your own words. It doesn't need to be in my words. Again, for the next slide, I would like you to just take a moment, try to do them yourself, and then come back. All right, as we go here, lowest power of x, do they both have x's? Yes. How many do they have in common? 4. Do they both have y's? Yes. How many are in common? 3. Over here, 24 and 36. You could break those up as we did a couple slides ago if you'd like and find the common factors there. The greatest common factor of that is 12. Then I look at the variables. Do they both have x's? Yes. What's the most they have in common? X to the 3rd. Do they both have y's? Yes. What's the most they have in common? Just one of them. We get to the next one. This one's caused a lot of trouble for different people. So do they both have x's? Yes. How many do they have in common? X squared. They have 2. Now this one has a y. Does that one have a y? No. So that's not common to both. This has z's. Does that one have z's? Nope. So that's not in common either. So our greatest common factor is simply x squared. It only shares that factor. All right. And then these are the answers to the others, which follow the same logic as before. This one may look unique down here because 5x to the 4th was actually one of the numbers we were considering. And this can happen just like if you had 2 and 6 and you said, what's the greatest common factor of 2 and 6? 2. So one of the the numbers you're looking at could be the greatest common factor itself. So that concludes our lesson on greatest common factor. It is important you understand because we're going to be applying this with some trinomial factors tomorrow.